I'm Madison, and this is the homeostatic challenges of Staghorn coral. So, Staghorn coral is Acropora cervicornis, that is its scientific name. It prefers warm, tropical, shallow, oxygenated water on coral reefs, and you can see that in the picture here. It is found throughout the Bahamas, Florida, and the Caribbean, and is one of the most important corals in the Caribbean as it has built the reefs there for the last 5,000 years. And you can see it is a golden tan, pale brown color due to the algae that lives in their tissues. The homeostatic challenge, that is any internal and or external stressor that disrupts the body's stable, optimal internal environment, which is homeostasis. Climate change and ocean warming, they are the greatest global threats of staghorn coral. Ocean acidification is the increasing carbon dioxide that makes it difficult to build the exoskeletons or their calcium carbonate structures. Again, higher temperatures and coral bleaching are a main factor that happens due to climate change and ocean warming. But ocean warming and coral bleaching, the rising temperatures can cause the corals to expel their symbiotic algae, making them become bleached, which you can see in this photo here. So staghorn coral versus thermal stress. Currently, the IUCN Red List has staghorn coral listed as critically endangered. This is mainly because a lot of them are bleached. Bleaching is during stressful temperatures, symbiotic algae will become toxic to the coral, causing the coral to expel the algae, becoming bleached. And this can also happen due to quick rises in temperature, which can cause declines in photosynthesis and respiration. Um, A. cervicornis, or staghorn coral, exhibits high mortality and large declines in photochemical efficiency. And again, the higher temperatures can cause a breakdown of the symbiosis, which we just went over. And here you can see a picture of the bleached coral. So the future of staghorn coral, there's going to be resilience to thermal stress through acclimatization and adaptation, which staghorn individuals are tending to host more heat-tolerant strains of symbiotic algae, which continue to function at higher temperatures with less cellular damage. There's another form of resilience called symbiont shuffling, which corals have been swapping out heat-stressed algae for tougher heat-resistant strains. And here, which is the most popular strain of algae that is a symbiont, is a Symbiodiniaceae. It reacts to heat differently than other strains of resistant symbionts. So there is more heat-resistant strains than just this one here. And there's also critical recruitment areas by the NOAA, and they are found in Puerto Rico, Florida, and the U.S. Virgin Islands that help to mitigate thermal stress and help the corals to revive themselves in these areas. And these are my references.